Hello, everyone. Thanks for a very warm welcome. And actually, welcome to the first day of talks at DjangoCon Europe. You all made it here, so congratulations. This is my second year at DjangoCon Europe, and I'm really excited and actually more nervous than the first time that I was presenting on the stage. So I'm really sorry. That's why, let's begin. To mock or not to mock? That is the question. A treatise narrated by me in a poor theatrical manner, as you have seen. My name is Anna, and I'm a proud member of Potato of London Town. We are a company that designs and builds complex, secure, and scalable web apps. Pdish, my bitch. And our favorite web framework is, unsurprisingly, Django. I'm relatively active on Twitter, and I mostly tweet short tips about coding, mixed with usual frustration and excitement. So feel free to get in touch with me. As you might have already anticipated, this talk is going to contain a lot of tests. When talking about tests, I bet everyone agrees that tests are, if not crucial, well, at least important. Whereas its unit test, or functional test, or super upper outer space test, they defend us from everyday bugs. They save us during regressions and cold winters. And as William Shakespeare said himself, thou shalt write tests. Chapter 1. Before trying to answer the question, let's take a step back and refresh our memory with a few things about mocking. Mocking means creating objects that simulate the looks and behavior of real objects. When testing real-world apps, like a Django app, for example, a single test can involve many complex dependencies. In order to isolate the behavior of a single object, we can replace real objects with mocks. This is especially useful when incorporating real behavior in our test is actually impractical. Think about it this way. The real object is like a Swiss Army knife with all the fancy, dangerous features that help you survive in the wild. Whereas the mock is the plastic toy knife. Firstly, it lost a hell lot of gadgets that the Swiss Army knife had. And secondly, it can't even cut. It's fake. It might look like it's real, but it's not. Now, this might be not the best analogy, but it's still a good start to understand what mocks can be. Another important distinction to make is that mocks aren't stubs. You might have heard things like fakes and mocks, stubs and dummies, and they all seem to be doing something similar in a way. You know, they contribute to unit tests, but they're slightly different. Now, what are stubs? Stubs are constructs that give us canned responses during tests. They usually do not respond to anything outside what's programmed in for the test. They also can retain information about the calls. On the other hand, mocks are pre-programmed objects with set expectations, which form a specification for the calls, which we expect to receive. Now, a simpler way to understand that is to look at how they're used in tests. So when you're testing, the first thing that you do, so in your unit test, you have, let's say, a setup method. So you start setting up your test. Then you perform the test. Then you verify the state which was saved on the stubs, and then you tear down. This was the example what happens when you use stubs. So this is how it goes with stubs. Whereas with mocks, the way we do it is we set up the test, and then we set the expectations, which means we take a mock and we tell it, like, you're going to return this value. And then we grab another mock and we tell it, you're going to have this property. Then we perform the test, Then we verify if our expectations are still kept there. We can verify the state as well, and then we tear down. Python has its own plastic toy factory, and it's called, unsurprisingly, mock. Mock module is available out of the box, starting with Python 3.3, whereas everybody else should install mock as a separate package. A moment of silence for those who still write Python 2.7. Other than that, the two packages are actually identical in the functionality that they provide. Mock module is very well documented, and if you scan through its docs, you can find plenty of less known features. But let's focus on those that you have probably seen more often. So in the spotlight, we have the mock. Mocks are callables, and they can fake any properties or behaviors. How? Like this. This is my crash course on mocking. There's a little snippet, and what we do, we import the mock class from the mock module, we create a mock object called m, tell it that it has an attribute foo and with the value 1. So we said before that mocks retain information. That's why when we access it again by doing m.foo, we get the value 1. In case we aren't telling it what the value of an attribute is, then it's going to return a mock. So you can see it for the m.bar. Magic mock is a subclass of mock with default implementations for most of the Python dunder methods, also known as the magic methods. You know, these guys. This is also, FYI, this is not the full list. And finally, patch, which can be used either as a function decorator, class decorator, or a context manager. So there's plenty of flexibility. Patches substitute objects only within the scope of the function they decorate or the scope of the context manager, depending on how you're using it. The key to patching is correct namespacing. Another crash course, this time on patching. We're patching a class called pony by specifying a path to it via a string. So the path to it is rainbow.pony. Now let's keep that in mind. Now, due to the specifics of patching namespaces, pony class might have been declared in some other places. Say it was declared in creatures.py, but it was imported and used in a module called rainbow.py. Therefore, the path to patching should point to the place where the object was used rather than where it was declared. So keep that in mind. Mock the object where it's used, not where it came from. Enough about that. Let's move on to chapter 2 and talk about talks that make our life easier and have good intentions. I call them the good mocks. And I have 5 examples with code, so brace yourselves. Really sorry. Let's start with system calls. Here we're patching a dictionary using a context manager. And if in our code we have a dependency on an environmental variable, in tasks we can use a mock to patch the OS environ dictionary and inject any variable we want, no needing to modify the real environmental variables. Then we can assert that a specific configuration file object, a configuration object was instantiated with a correct value that is dependent on our OS environment. Similarly, we can patch anything, almost anything, on OS or sys module. And that way, our tasks can become system agnostic. Since we were talking about OS and sys, how about streams? How do you test std out, or how do you test std in? Actually, no need to try to simulate that, though this is probably possible. We can mock std out altogether. and replace it with a string IO object. And then we can assert what was the value that got printed in our silly logger. Let's move on from system-related problems to web-related problems, the ones that are close to our heart. Everyone likes request, isn't that right? Sometimes in our apps, we need to make a request to an external service over which we have no control. Now, we don't want to start having failing tests because their website crashed or because the network is down. That's why we mock this behavior by patching requests.get method, and no more problems with that. Remember we talked about magic mock and that it has dunder methods like underscore underscore enter and underscore underscore exit. Well, this allows us to mock working with files. When we are testing, rather than creating files and then creating test files and then opening them, reading from them, writing, resetting them during tests, we can just use patch and mock open helper method from the mock library. We use the mock open to tell it what data do we expect to read from the file, because it might not even exist on our file system. So we can do that by matching the open method, context manager basically. Moreover, with this, you'll gain a nice speed improvement for your tests. How about time-related stuff? Taking as an example a Django app that has time zone awareness enabled. If we have some customization based on our user time zone, there is no need to relocate ourselves to Tokyo or change our system time zone to get a Tokyo localized edge case. Same principle can be applied to any time-related stuff. And what we're doing now is we are replacing time zone now return value with a Tokyo time zoned datetime by using mock patch object. And my favorite one is randomness. Needless to say, that'd be a very handy thing for gambling. Are you still awake? Are you still there? Yeah? Oh, if you missed something, don't worry. We're going to go back right now and take it all over. Yeah, of course, I'm kidding. No more torture. But I can give you a recap what are the good mocks. And those are the system calls, the streams, HTTP requests, responses, I/O operations, clocks, time zones, and unpredictable results. Now, why do we consider them good? Well, because they save us time. Remember about the I/O operations? They make impossible possible. It would have been pretty hard to get exactly 0.42 from a random function. And they exclude external dependencies like fetching data over the network. Chapter 3, titled Bad Mocks. In this chapter, we will look at some usages of mocks in tests that can yield undesired results. This is the last snippet that you'll see, I promise, and I'll guide you through it. It's a test from a Django project. On the first line, we mock the save-based method of a pony model. Our reasoning is that we don't care what happens to the model. We just want to test the validation in an isolated manner. We create the form. We pass the pony instance. We pass some form data, check if the form is valid. We save it. Check if some object attribute was set correctly, and check if the mock save method of the pony was called exactly one time. Now let's play a game. And the game is spot the error. What is the first thing that makes you cringe here? It's actually not even related to mocks, it's just like general testing thing, so you can start shouting at me. What is it? maybe, I'm not sure, but there's something here on the surface. Yes, this is the one. So take a look at that. It says self-assert true, saved pony.age free. Well, that seems ridiculous. I mean, it's going to be true as long as the age is not 0. Is that right? And this is actually a copy-paste mistake, most probably. So let's just keep in mind that this kind of things happen, and of course, let's correct that. Now, this looks slightly better. What else is wrong here? What on earth could possibly go wrong with this nice-looking test? Are there any ideas? I'll give you a hint. How about this line? Sorry? Oh, that's really true. That's really true. But that's something we'll address slightly later. Thanks, Pablo. This method does not exist. What if we say mock assert called twice? This is still going to run without errors, you know? And so now it's not clear, like, is it saved once or is it saved twice? I don't get it. What if I tell it to make me a sandwich? I know, that'd be really awesome to have a test of make me a sandwich. And yes, it will do. Well, why? Because the mock objects creates all attributes and methods as we access them. It's mocking 101. And this method doesn't exist in reality, and it was just mocked, so it just passed through. We were not careful enough to double-check the mock API and made a little typo, and that will keep passing our test with never checking if the save was actually called. Why did this happen? Clearly, we don't like spending time reading mock documentation, especially when it seems like it's working, you know? Remember that copy-paste mistake? You know, people might keep copy-pasting this one as well. And this kind of faulty test checks can propagate a really, really long way. You might ask, well, what happened to the code review? You know, didn't the peer see the problem over there? Well, I mean, sometimes you have to write like a 10-line function, and then you need to write 10 test cases for it, and there are like 300 lines. And I mean, I'll understand if my fellow developer will just skip checking each line of tests. I tend to trust my teammates and think that their tests are accurate. Let's go back to the code. And the original intention was to do this. Assert called once with. This method actually exists. And then you also need to pass the parameters with which the save method was called, but not doing that. This is the first solution, but this is prone to error, as we have seen. That's why, better let's do this. Let's do assert equal mock save.call count, and then check if it was called once or twice or 3 times or zeros. You know, you can just assert as you wish. And we can't do silly things like that. We can't say, you know, sandwich count, was that 1 or was that 2? That will not work, because in this case, sandwich count will be what? A mock. And the third solution is maybe you could do some TDD, because a non-failing test at the beginning will probably raise an alarm in this case. These 3 solutions are not the only ones. There are other ways to prevent this kind of problems. So mock object has a special param that you can pass, and it's called autospec, and it will recreate your original object with the same properties and methods as the original one, not adding or removing any of those. So then you can make sure that the mock doesn't have anything extra. You could also replace the mocked object altogether with a new object, same as we did with I/O operations, because we said, okay, so std out, I don't care about it, I want to replace it with a string I/O. Now, since this is settled, what else is wrong here? Ask yourself, why do we mock pony.save method? The reason we might do that is because of the speed gain. Mocks operate in memory, whereas saving a model will make a write to the database and steal some extra milliseconds from our test runtime. Sometimes that does really matter when we have hundreds of tests. But is it a good idea to mock save? Or is it a bad idea? What if we have some extra hooks performed on the model? What if the data will just make the model save fail? What if we have pre-post save signal, Pablo, you're not listening? Well, we never know, because we never call save. You might say, well, I know what I'm doing. I'm not messing with my model save method. I'm not enabling signals here and there for obscure reasons. Well, yeah, but what about the next developer? I mean, they don't know about your best intentions. What about the new requirements that will come up with time? Moreover, as we have seen, no one will review tests to check if they're still valid until they fail. But everyone will trust a hefty number of passing tests. Test pass? Ship it. How many times have you heard that? I'm not saying that test is bad. Maybe, just maybe, it's incomplete. Now, what I'll try to explain might be a bit controversial, so bear with me. To me, Django as a framework is like a rainbow cake with many delicious layers. It's good we had lunch, right? Those layers are interlinked with each other in one way or another. And when we want to test how the layers operate together, we need to write functional tests. At the same time, it's perfectly valid to write unit tests, say for our business logic. And if it happens that your business logic is inside a form, well, yeah, use a mock for stuff you don't care about. But please, please, provide a functional test that will transcend through all the necessary layers of Django to perform one single user action and see how the form validation fits into the big picture in this specific case. The takeaway from this is use mocks carefully in your unit tests. There is a little heart between unit tests and mocks. And use both unit tests and functional tests as you need them. They do operate together well. But hide mocks away from your functional tests as much as possible. There is a broken heart. This brings us to the end of the story. Not to scare you, but mocks can be dangerous. They will hide what shouldn't be hidden and leave you with a false sense of security that everything is fine. Thank you. Any questions? No, I'm fine.
Thank you very much, Anna. We've got time for some questions, so if you want to ask them, queue up on this side. And before we start doing that, let me just state that questions are questions, statements are statements. This time, we're asking questions. If you want to make statements, Lightning Talk are a better platform for that.
Thanks very much. You were talking about mocks, and I've used mocks myself, and they're a fabulous tool in the arsenal. But are there any times when you think you shouldn't be using a mock, or the need to use a mock is indicating a larger problem with your code base? I'm thinking I have seen many examples where people, rather than use mocks, then go and reorganize their code in such a way that the mock isn't actually required in the first place. Is that a better approach to re-architect the code so that you don't need to mock, or can we just use mocks without caring about any of that?
It's definitely, if you started building the whole structure from the bottom up, and you're trying to mock something that is inside your own logic, and you're trying to use too many objects, and you have like this crazy inheritance, and that's why you're starting mocking. But if you think about Django, Django is so packed together sometimes. So that's what people are trying to do. They are not able to separate some of the things from Django. They can't restructure it. It's not that easy at this point, I believe. So that's why people sometimes start using mocks. But yes, definitely. If you feel like you need to use mocks for every single thing you're doing, take a look at your code. There's something wrong with your whole hierarchy or structure, or you need to just rethink, redesign. Thanks.
As developers, we all know how important it is to test and mock and do all that. And since you just held a talk about testing and mock, you must have some great tips on how to convince product owners to invest the time and money to actually give developers opportunities to mock and test.
Wow, this is the most complicated question ever. I've never made a sales pitch to business people. And the company that I work currently, tests are kind of the implicit thing. Things don't exist without tests. So how would I start? If I would have been in that situation where my company doesn't want to invest time into writing tests, what would I have to?
I guess that's a better topic to discuss privately after this.
Yeah, I mean, I don't know. Try it out. Try to pitch it. Try to convince them. Tell them then maybe it will convince them. Like telling them everybody's doing that. That's the trend. That's what the cool things do. Cool kids do. Maybe. I mean, if the reason doesn't work. If the voice of reason doesn't work. Sorry.
All right, that's the end of questions. Thank you very much, Anna. It was a great talk. Awesome.